So these are the questions that sort of will be in final exams. So since this is my last lecture, not to say my last lecture, last class, then hopefully that we can have a closure on what should be expected in your final exams. Apart from your assignment, the 35%, I hope everybody is clear on what to do. And this is your 30% for your examinations. So these are types of questions. And we will look also at what kind of answers expected from you. But I hope to have active participation. As I mentioned, at least you give me the keywords. What are the keywords that should be in the answer for these questions? So let's go through the questions. Okay, explain the differences between fluorescence and phosphorescence, because these are basics. We have learned, we have discussed on AS, AES, as well as atomic fluorescence. So you should know also some basics of fluorescence and phosphorescence. Okay, so I think I just throw the question to you. What do you think should be in the answer? Just keywords.
The time scale.
Sorry, can you be louder, a bit louder?
Okay. The differences between fluorescence and phosphorescence. First, the time scale. Because fluorescence occurs almost instant emission of light, stopping as soon as the excitation source is removed. Whereas the phosphorescence continues to emit light even after the excitation source is removed. It can persist for seconds, minutes, or even hours.
So that's one good point. Is actually delayed. So that's one good point. Actually, the question consists of 5 marks. So when you have this kind of question, you have to look at the marks. Okay, I didn't put marks, but for you to know how to answer question, you have to look at the marks. So the marks is actually for this question is 5 marks. So now you have come up with 1 point. Okay, so what about the rest? Thank you, Idayu. Was Idayu, right?
Yeah.
Okay, Omar?
Yeah, actually, if we need to combine fluorescence and phosphorescence, we need to talk about mechanism, energy realized, relationship between the absorbed and the released energy. The absorbed amount of energy realized back in fluorescence.
Can you be a bit more specific? Is it the process of producing fluorescence and phosphorescence? Because if you don't answer according to the keywords, you might lose marks. So what are the keywords that you want to point out here?
Yeah, if I mean, if we need to compare between fluorescence and phosphorescence, we need to talk about diffusion and the time in process, the mechanism, the energy realized, the relationship between the absorbent and the realized energy. If we go to the fluorescence, like energy realized is higher than that in the phosphorescence.
I get it, but you have to be very, not to say too specific, but you have to explain the process clearly. Clearly. So Ida, you talk about time. The fluorescence is actually being produced very fast, whereas phosphorescence is a delayed, sometimes it is called a delayed fluorescence. So that's one point. The second point, probably from Omar, you're talking about mechanism. But when you're talking about mechanism, you have to be very specific. So it's easier if you talk about the Jablonski diagram. Remember the Jablonski diagram? So this is science. You have to if you have difficulty in writing in sentences, is actually very easy if you assist your explanation using diagram. Okay, you explain, you write, you draw the diagram and then explain. Yeah, so that is much easier. So thank you, Omar. So now we have 2 points. What are the 3 points that you can put in this answer? Any more suggestion?
Can I try the first?
Yes.
Fluorescent give an immediate flash or afterglow on
Correct.
exposure.
Mhm.
Phosphorescent appears to glow in the dark because of slow emission of light over time.
Mhm. So I think it's quite similar to the previous 2 answers. Okay, but it's okay. All right. You can also talk about the instrumentations if there is a big difference. The light source, if there is a difference. But in this case, fluorescent and phosphorescent, there is no difference in terms of instrumentation. Okay, but it's okay. So to speed things up, okay, I will show the suggested answer for A and B. But now let's move to B first. Okay, I hope to get a different person. Just now is Hamima, right?
Yes. Yes.
Okay, Hamima. So let's look at B, question B. You have benzene and you have bromobenzene. Yeah. So the biggest difference here is bromine. Yeah. So now if we look at the intensity of the fluorescent intensity of benzene and bromobenzene, we can find that the bromobenzene has lower fluorescent intensity. Can someone suggest why? Let's have different people. We have answer from Idayu, Omar.
Hello.
Yeah, Junming.
Is the reason is because of the heavy atom effect from
Yes.
hydrogen.
Yes, correct. Obviously, yeah, it's a heavy atom effect. Okay, so I'm going to show you later the suggested answer for the first one. Okay, let me unshare this one first. Right. Okay. Mm-hmm. Yeah. One. Got it. Okay. This share. Right. Share screen. Okay, when you're working with 2 devices, so please bear with me. Just a moment, yeah. All right, let's find the exam. Okay, let's find exams. Let's find exams. Okay. I hope that you can see my screen, the fluorescence and the phosphorescence. Okay. If it is not big enough, I think still it is readable. So we talk about, so since you have to look at the question, how many marks are required by the questions. So if it is 5, then you have to find 5 points to answer the questions. So you are given more than, for this answer, you are given more than 5 points. It's okay. So if you look at here, it is the absorption energy of by atoms immediate emission. So I think Idayu mentioned about that. For phosphorescence, delayed emission, okay? And also the answer on the emission of the radiation remains for some time, even after the removal of source of excitation. So that will be another point. The excited atom has comparatively short lifetime. Remember about the fluorescent has the same spin, okay? Electron spin. So it is the electron has shorter lifetime, so that's why you have immediate production of fluorescence. Whereas in phosphorescence, the excited electron actually have a different spin. Okay, so it has longer lifetime. Yeah, you can refer back to our notes. Yeah, all right, just okay. And Omar mentioned about the process. Okay, how it happens. So you can see, you can have the Jablonski, a simple Jablonski diagram. Okay. So you can explain how fluorescence happens, and then how phosphorescence happens. You can talk about the intersystem crossing. You can also talk about the process of fluorescence. So these are the things that you can discuss according to the marks given. And the second question is on the heavy atom effect. Yeah. So please make sure when you answer, okay, you have to use the right keywords. If it is intersystem crossing, then it should be intersystem crossing. You cannot just use any words that you think you want to explain using different words, because in science, keywords are very important, right? So you have to try your best to use the keywords that has been discussed in lectures. Yeah, so these are very important. Okay, so understanding the process and also okay, when you draw figures or diagrams, it is very important to label the diagrams. Yeah? You cannot just put E expecting the marks, the lecturers or the one who marks the answer understand E is what. Okay, you have to label all the diagrams. So that's how you should answer the questions. Okay. Okay, I'll stop share this one. Back to the question just now. Okay. So number 2, okay, an atomic optical spectroscopy means that it is general. It's not. It concerns AAS, AES, as well as AFS. Yeah. So it's used for determination of elemental composition by the electromagnetic radiation. Name 5 important components in this technique. So please, this means the instrumentations. Yeah? What are the main instrumentations requires for all these techniques? Okay. Can we have suggestions from you?
I can, Prof.
Yes.
Clinical pass, light source, optimizer, optical system, detection system, data processing.
Okay. So we have usually around five important components just mentioned by the show, that we need a light source, we need the chromators, monochromators. We also need atomizers. We also need detectors, as well as display. Okay, to display the output. Okay, so these are not difficult because it is quite common in the spectroscopy technique. Okay, let's go to B. And in AAS, the precision and accuracy of atomic methods depends critically on the atomization step by using flame or flameless method, because we have flame method as well as flameless method. So number one, what are advantages and disadvantages of flame AAS as compared to the graphite furnace AAS? Okay. Okay.
Can I answer?
Yes.
I
Yes.
think
Yes.
the main advantage is a greater sensitivity, concentration, and especially mass.
Concentration. Sorry.
Greater sensitivity in
Okay.
concentration and especially mass.
Probably I cannot hear you clearly, but I can hear some parts of your answers. Let me. Okay. It's
Sorry.
fine. Okay. Right. So just a moment. Give me a moment to. Right. Okay, acceptable. But please do check back, okay? Because when we use flame AAS, it is one is high sample throughput and then high precision. Okay, I'm referring to the answer, but I think your answer also acceptable. And depends on the mark. In this case, like say you have 4 marks, okay? So you need to have 4 points. Yeah. So please do check again on the answer of flame AAS versus graphite AAS. The answer given to me is because it is in fact inexpensive. It's not expensive. High sample throughput, easy to use, and high precision. Okay. Disadvantage. Okay. So Omar is talking about advantage. What about disadvantage?
I can. Prove.
Yeah. Yes, please.
But only solutions are capable to be analyzed in flames. 2. Refractory elements may pose problems. 3.
Yes.
They compared to graphite. 4. Large sample of the order 1 to 2 milliliter must be added.
Yeah. Only a single solution can be analyzed at one time, and then we have problems with refractory elements. Yes. But the disadvantages, because Omar answered about sensitivity, because actually flame AAS, it is less sensitive compared to graphite furnace. Yeah? So please check on that answer. Yeah?
Bro,
Okay.
we can say the instrument complexly in a disadvantage.
The instrument can
Complexity.
Complexly.
Yeah, we can add at this point, or
actually I don't understand. The advantages of let me repeat, the advantages of flame AAS, high precision, but it's not sensitive. Yeah. Because high precision means that you can have very precise, okay, but it's not sensitive, meaning that you cannot identify a very low concentration. Okay, and definitely easy to use because it's flame. You can just dump everything in a flame. So you can also have high sample throughput, means that you can just run a series of your solutions. But at one time, you can only run a single solution. So you cannot just mix everything together. Right? Less sensitive, okay, because of the detection mechanism. And then, of course, it's easy to use. Okay, it's okay. This kind of question you can check back. There's a lot of possible answers for you to check, to suggest for this question. And then number 2, flame absorption profiles for 3 elements. Okay, describe each element based on their oxidation property. Okay, right. Any suggestion?
I can prove.
All right, wow. Okay.
To competing process affects the concentration of free atoms in the flame. The more time the element spent in the flame, the greater the atomization efficiency. Thus, the production of free atoms increases with heat. On the other hand, a longer residence time allows more opportunity for the free atoms to combine with oxygen to form a molecular oxide. For an easily oxide metal, such as Cr, the concentration of free
Chromium.
atoms is the greatest just above the Brunner head. For metals, such as Ag, which are difficult to oxide, the concentration of free atoms increases steadily with heat. For magnesium, with oxygen has a slightly slower peak in the middle. Other atoms shows concentration profiles at a maximus at a characteristic height. That's all.
All right, thank you. Your answers are correct. Okay. Talking about magnesium, but you should talk one by one. You talk about chromium. Okay. Forms a very stable oxides. Okay. Whereas argentum not easily oxidized. Magnesium initially increase in absorbance as the distance from the base. I will share the answer later, but let us discuss this. Okay, I will arrange the answer for you, but then it's good that you have suggestion from your owner. Sometimes, of course, the answers came probably not 100% similar to your answer, but it's okay. Okay, it's also acceptable. Now let's move on to the next questions. Hollow cathode lamp is found with commonly light source. Explain the reaction between argon and the metal atom that normally occurred in HCl, in hollow cathode lamp. All right. So this one actually, what do you think the answer is? Which process?
Collisional excitation process.
Excitation. Remember
Collisional.
about, sorry, conditional?
Collisional excitation process.
Yes, one of it. There is excitation, there is sputtering. Okay.
And
Okay.
emission
Yeah.
of energy.
Yeah.
Mm.
You want to share, or you can just talk about it? What are the process? Junming, right?
Okay lah.
You just tell the process, because
Its first will be like excitation from electrical
yes, correct.
electric potential to the argon, and then excited argon will like collide with the metal cathode, right? And
Yes, correct.
sputtering occur. So will like sputter and will form like the metal cathode atom. And if bombardment by the charge, the excited argon will then excite the metal atoms within. And when it reach to excited state and drop back to ground state, it release emission of energy in the form of light.
Yes. Thank you. That's great. So it's just that you just like arrange the answer properly. Okay. First point, second point, so that I think it should be all right. Okay. The next one, an atomic optical spectroscopy is used for blah, 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 give the basic similarities and differences between AES and AAS. So this quite favorite question. Okay, any suggestion? I'm trying to find. Any suggestion for these questions? Definitely one is absorption, one is emission. Okay.
Both same sample preparation.
For similarities, right? You're talking about similarities, okay? Sample preparation, probably.
Both can provide the concentration of element in sample.
Yes, quantitative elemental analysis, yes. Okay, quantitative analysis, sample preparations, and they also suffer from interferences, right? They have this kind of chemical interferences, spectral interferences. So those are also similarities between AAS and AES, yeah? And both use atomizers, right? Okay, they both use atomizers. And those are similarities. What are the differences? One I have mentioned, definitely the emission. One is absorption. So you can talk about the process. Okay, you can talk about the emission and absorption. Any other differences?
Prof.
Yes, they should. Okay. It's okay. Anyone can answer.
Okay. Okay.
Mm-hmm.
You
Can I answer this question?
You don't understand the question?
No. Can I answer the question?
Okay, yeah. Okay, Leshu, can we give someone else to answer?
Berebut lah. Berebut.
It's okay. It's good. It's good.
AES
Okay.
Is more sensitive than AS.
Okay.
AS can detect trace amounts of elements at
Mhm.
lower concentration, for example, parts per billion, whereas AS usually it can detect the concentration at the range of ppm only.
Yes. Okay. All right. Lishu, you have any other answers? Lishu.
transition is ground to excited. AES is emitted, and the spectrum AAS is colored spectrum. AES is dark lens, and source AAS is hollow cathode lamp, and AES is hideout light. And dependence AAS is ground state atoms, and AES is excited state atoms. That's all.
Right. So just now is Hamima, right? Hamima?
Yes, Prof.
Okay.
I'm Hamima.
Just because I'm looking at my different screen, so I cannot see who's answering. Okay. So when you talk about sensitivity, because it's actually different according to the if it is ICP, inductive coupled plasma. All right. So, but the basic is if you're using emission spectrum, you can do multiple analysis at one time, right? But if you're using absorption spectrum, you only do a single element at one time, okay? So probably due to that specificity of the emission spectrum, you can have more elemental analysis at one time. But in terms of sensitivity, whether it's part per billions, it depends on the instruments. Am I right?
Yes.
It depends on the system. Okay, so it's okay. Generally, yes, AES is commonly more sensitive compared to AES. Yeah. All right. Where is it? Number 3. Okay. Right. Interferences list down 3 important stages involved to ensure reproducible atomization in graphite furnace AAS.
I can, Pro.
You're very active today. So what are your suggestions?
In the first stage, the sample is dried to a solid residue using a current that raises the temperature of the graphite to
Yeah.
about 110 degree. In the second stage, which is called etching, the temperature
Etching, yes.
the temperature is increased to between 350 to 1200 degree. At these temperatures, any organic materials in the sample is converted to CO2 and water and volatile inorganic materials are vaporized. These gases are removed by the intergas flow. In the final stage, the sample is optimized by rapidly increasing the temperature to between 2000 to 3000 degrees. The result in a transient absorbance peak whose height or areas is proportional to the absolute amount of energy injected into the graphite tube. Together, the three stages take approximately 45 to 90 seconds, with most of the time used for driving and etching the sample. That's all.
That's all. Yes, you need, there are 3 keywords there. You have to dry, and then you have to etch, etching process, and before the atomization. So thank you. That's very comprehensive answers. Okay. All right. So to ensure reproducible atomization, so this process has to be done every time. Dry, etching, and then atomization. C interferences are normally involved in optical atomic spectroscopy and give effect on signal when analyte concentration remains unchanged. Okay, this is talking about interferences. So list down 2 types of interferences involved in optical atomic spectroscopy. I think these are very easy answers because we have chemical interferences as well as spectral interferences. I think because the question asking about 2 types, right? But I hope you know, you can explain well what is spectral interferences, what is chemical interferences. You should know how to give some examples as well. And also you should know how to counter, how to solve, how to suggest the solution to counter the issue of spectral interferences and chemical interferences. Yeah? So those are, I mean, things that you can refer to the lecture notes before. Yeah? So briefly discuss the best solution and how to solve the problem when the formation of compounds of low volatility occurred in AS. Okay. Right. Just give me a moment. I need to talk to somebody. Right. Just give me a moment, yeah. Why is it not screenshot? Ah, okay. All right, sorry. I have to manage my children. Okay, briefly discuss the best solution on how to solve the problem when the formation of compounds of low volatility occurred in AAS. So this is an example. Okay. Can you hear me?
Yes, Prof.
Yes, Prof.
Yeah, sorry. On this is example of it might be chemical, it might be, I think it's chemical interference. Yeah. So anyone has suggestion for this? Just key points.
I have three.
Yes. Yes, yes, please.
Increased temperature.
All right.
Adding release agent.
Correct.
Adding protective agent.
Yes. Okay. So you can also give some examples of what kind of release agent as well as protective agents. So all these are in our lecture notes, yeah. Okay, because these low volatility compounds will contribute to the interference in AAS. Because of the low volatility, it might it is difficult to volatilize the compound. So you can of course increase the temperature by using a different fuel, okay, fuel source, and mentioned by Junming that you can also use release agent as well as protective agent. So release agent, there are certain example of release agents. So you can use strontium, lanthanum. Protective agent, you can use EDTA or other ligands. Yeah. So next questions is, in the analysis of groundwater sample by flame AAS for barium, the presence of high amounts of calcium gives rise to molecular interference due to the presence of a broad molecular band of calcium hydroxide. Okay. Okay, the researcher will find a solution to solve the problem, such as by utilizing deuterium background. Okay, this is one example of solving the issue of interference. Or swapping to a nitrous oxide flame means that you use different flames, different fuel. Explain in details how these two solutions are working. B, suggest one other instrument that can be used to overcome this problem. C, explain the working principle and advantages by using the suggested instrument in B. Okay, just keywords. Probably we can have someone else. This one is a bit, a lot of marks, okay? You can, if you have difficulty, because this actually requires a long explanation, and the best explanation is by using diagrams. You have to like alternate the deuterium light. So I'm telling you, utilizing deuterium background can be used to provide background correction. In this technique, radiation from a deuterium lamp and HCl lamp alternately pass through the graphite tube analyzer. So this one is okay. I believe this kind of questions will not come out in your final exam, but this is very important for you to know this, because this is one of the ways to counter the issue of interference. Yeah, right. Suggest one other instrument that can be used to overcome this problem. Well, the answer you can suggest ICP. Okay. All right.
I can prove.
You want to answer?
Jimmy, you can.
Yes, yes. You want to answer or you just want to give some keywords? Okay. You can just give some keywords.
Using continuous source such as D2 lamp.
Mm-hmm.
And because D2 lamp is a continuous source
Mm-hmm.
of its radiation by the analysis narrow absorbance lines is negligible. Only the background therefore absorbs radiation from D2 lamp. Both the analysis and the background, on the other hand, absorb the halo cathode's radiation. Subtracting the absorbance for the D2 lamp from that for the hollow cathode lamp give a corrected absorbance that compensates for the background interference. Although this method of background correction is effective, it does assume that the background absorbance is constant over the range of wavelengths passed by the monochromator. If this is not true, then subtracting the two absorbance underestimates or overestimates the background. A typical optical arrangement is showing as a finger in chat box.
Yeah, yeah. It's okay. It's a long answer, I understand. But then this one is not really important for final exam, okay? But then I need everybody to at least understand how we can use deuterium lamp, okay, D2 lamp, to solve the problem of interferences. So because you have to understand that in order to use that, the system has to alternate the slit width. Okay, I think I have shared before one YouTube video. Okay, that shows a very nice animation on how to use deuterium to solve this issue. Yeah. So one is deuterium background. All right. The other one is using nitrous oxide flame. Okay. Because it has higher temperature. So for question B, the suggestion here is ICP, OES. Okay. And then whatever your answer it be, uh, you have to answer C, the working principle. Because we are talking about interference, so that's why by having atomic emission instead of atomic absorption, you have more specificity compared to the AAS. Yeah. All right. So I think that's all. Yes, Jiming.
I want to ask about the other instrument part, like because can we like use the magnet one, the one that involves Zeeman effect?
Yes. But here the question is actually talking about the issue of if because you're doing analysis for barium, okay, but you have interference from calcium, okay. So it's quite specific problem, okay. You're talking about Zeeman effect. That one is to, yeah, it can be used to reduce the effect of interference. Um, if the question asks quite general, then that can also be used as an answer. But for this one, I'm not sure.
Because
But,
at first I understand the question as like adding on additional instruments, like still using flame AS but adding stuff into it, like bring a deuterium lantern or something. Do you think or like just change, just not using flame AS?
Yeah, I get your what you mean is adding some extra parts to AS, not suggesting a totally different technique from AS. Okay, I understand the questions. I understand the issues here. Suggest one other instruments that can be used to overcome. Yeah. So as I mentioned, it is acceptable if your answer is different from the answer scheme, because the answer scheme not for me it's not necessarily important to have it uh, exactly the same. So I do accept your answers if it is logical and it is scientifically is scientifically sound. So it's okay. During the final exam, if you think that the question is like not clear to you, you can ask about the question. Okay, what is the question asking for? Is it a totally new, for example, this question, is it a totally new, is it instrument means additional instrument, or is a different method? Yeah. So it's okay, Junming. So if you have that kind of concern, everybody can ask during the final exams. You don't ask for the answer, but you can ask for the clarity of the questions. Yeah. All right. I think we have covered everything. I will try my best to share the answer later with you. Any other concern?
Just let's say for the suggestion for the instrument,
Mm-hmm.
let's say we suggest the graphite furnace AAS.
Mm-hmm.
So is it we can get the marks from there, or how about the